Right now, as you hear this, statistical physics, the same branch of physics that built nuclear reactors and predicted black holes, calculates that a disembodied brain, floating alone in an empty void, with every single one of your memories, your name, the feeling of your body in this chair, the sound of this voice, is more likely to exist than you are. Not metaphorically, mathematically. By a margin so large the number doesn't have a name in any human language. There is a tombstone in Vienna. It belongs to the man whose equation made this calculation possible. 5 symbols, carved into stone. We'll get to what they mean, but first you need to understand what they cost. On September 5th, 1906, a 62-year-old physicist stood in a hotel room in you.No, a small village on the Adriatic coast. Outside, the bay glittered in late summer light. His wife Henriette and his youngest daughter Elsa were swimming. He could probably hear them from the window. Laughter, maybe. The sound of water breaking against skin. His name was Ludwig Boltzmann, and in the time it took for his family to swim to shore and back, he hanged himself. No note, no explanation, no final equation. The people who destroyed him were not strangers. They were his colleagues. To understand what happened to Boltzmann and what his death has to do with the question of whether you exist, you need to understand one law. Just one. The second law of thermodynamics. A glass falls off a table and shatters. You've seen this. Everyone has. But you've never seen the reverse. You've never watched shards of glass leap off the floor, reassemble mid-air, and land on the table as a perfect, unbroken glass. The second law says why. Disorder increases. Entropy, the measure of how many ways matter can be arranged, goes up. Always. A shattered glass has more possible configurations than an intact one. Nature moves toward the probable. The glass breaks because breaking is overwhelmingly more likely than unbreaking. This seems obvious. This seems like something you already knew. Boltzmann saw something inside it that no one else could see, and it nearly drove him mad. In 1877, working at the University of Graz, Boltzmann proposed something radical. The second law, this iron rule that disorder always increases, is not actually a law. It's a bet. It's overwhelmingly likely that entropy increases. Not guaranteed, not mandated by the fundamental equations of physics, just staggeringly, absurdly, almost but not quite certainly probable. A shattered glass could reassemble itself. Every single particle could, by pure chance, bounce in exactly the right direction at exactly the right time and reconstruct the glass. The probability is so low it would take longer than the age of the universe to expect it even once. But it's not zero. Not zero. That distinction, between impossible and merely unimaginably unlikely, is the crack in reality that this entire video falls through. To make his case, Boltzmann needed atoms, not as metaphors, not as useful fictions, as real physical objects whose motion could be described by probability. His entire framework, statistical mechanics, depended on atoms being actual things that actually exist. The problem was that in 1877, nobody had ever seen an atom. Nobody could prove they existed. And the most powerful physicist-philosopher of the era, a man named Ernst Mach, made it his mission to ensure nobody ever tried. Mach didn't just doubt atoms, he was offended by them. Science, he declared, should be built only on what can be directly observed. Atoms couldn't be seen, they couldn't be measured. They were a fantasy dressed up in equations. And he said so publicly, repeatedly, and to Boltzmann's face. After a lecture Boltzmann gave at the Imperial Academy of Science in Vienna in 1897, Mach stood up and delivered 5 words that would follow Boltzmann for the rest of his life. I don't believe atoms exist. 5 words, from the most respected philosopher of science in Europe, in a room full of the people Boltzmann needed to convince. You are made of atoms, 67% oxygen, 18% carbon, 10% hydrogen. Those atoms are real. A man destroyed himself so that you could know that. Actually, no. That's not quite right. He didn't die so that you'd know. He died because nobody believed him. The knowing came later. Too late. Through the 1890s and into the new century, Boltzmann fought. He published papers. He gave lectures. He argued with Mach at every conference, in every journal, at every opportunity. But the attacks weren't just intellectual, they were personal. Mach and his allies controlled the major German physics journals. They refused to let Boltzmann refer to atoms as anything other than convenient constructs. He was allowed to use them in calculations. He was not allowed to say they were real. Boltzmann's mental health collapsed. He experienced what would now be diagnosed as severe bipolar disorder, periods of manic productivity followed by crushing depression. His eyesight deteriorated until he could no longer read his own papers without help. He moved restlessly from university to university. Graz, Vienna, Munich, Leipzig, back to Vienna, never staying, never settling, as if the physical act of leaving could outrun the feeling that his life's work was being erased. In Leipzig, surrounded by intellectual enemies, he attempted suicide for the first time. He survived. He returned to Vienna. But by 1906, his physician formally attested that Boltzmann suffered from severe neurasthenia and ordered him to cease all scientific activity. His body was failing. His mind was failing. And the people whose approval he needed most, the physics establishment, still would not say the word atom without quotation marks. September 5th, 1906. you.No, the bay, the swimming, the silence. Here is what happened next, in the world he left behind. In 1905, 1 year before Boltzmann's death, a 26-year-old patent clerk in Bern named Albert Einstein had published a paper on Brownian motion, the random jiggling of tiny particles suspended in liquid. Einstein's math showed this jiggling was caused by individual molecules colliding with the particles. If atoms were real, the math predicted specific, measurable patterns in that jiggling. In 1908, a French physicist named Jean-Baptiste Perrin tested it. The math held. The patterns matched. Atoms were real. 2 years too late, Boltzmann was right about everything. The atoms, the statistics, the probability, all of it. And on his tombstone in the Zentralfriedhof, Vienna's central cemetery, they carved the equation that contained his deepest insight. S equals K log W. 5 symbols. Entropy equals a constant times the logarithm of probability. Disorder is not destiny, it's likelihood. And in that equation, in that single, beautiful, devastating line of mathematics, is hidden something Boltzmann never saw. Something that wouldn't be named for another 98 years. Something that points at you, right now, and asks a question you cannot answer. There's an equation on his tombstone, 5 symbols. We'll get to what they mean. But first, you need to understand what they cost, not just to him, but to the universe. Because to follow Boltzmann's math to its final conclusion, you have to walk past the death of a man and into the death of everything. S equals K log W. Entropy equals probability. Boltzmann carved that into eternity. He didn't know, couldn't have known, where that equation would lead. To understand what it costs, you have to follow it to the end, the actual end, of everything. Here is what happens to the universe, not what might happen. Not in one model among many. In every model that survives contact with evidence, the ending is the same. But before the ending, a brief and bitter triumph. Paris, 1908. A 37-year-old physicist named Jean-Baptiste Perrin is hunched over a microscope in a lab at the Sorbonne, and he is counting specks. The specks are particles of gamboge, a bright yellow pigment extracted from the latex of trees in Cambodia and Thailand. Perrin has spent months grinding this pigment, dissolving it, centrifuging it, filtering it, over and over, until the particles suspended in solution are nearly identical in size. A task so tedious and so precise that almost no one else in the world could replicate it. He is not doing this because he enjoys it. He is doing it because he believes he can see atoms. Not directly. You can't see atoms. Even today, you can't watch a single water molecule collide with a grain of dust. But you can see the result. The specks of gamboge, suspended in water, jitter. They drift in random directions, stop, reverse, drift again. Robert Brown noticed this in 1827 while watching pollen grains, a dance with no music, no source, no explanation. 80 years later, no one had proven why. Einstein, in 1905, had given the math. If water is made of molecules, real, physical, countable molecules, then those molecules are in constant thermal motion. They collide with suspended particles from all sides. The jittering you see under a microscope is the visible signature of an invisible war. Billions of molecular collisions per second, each one a tiny shove in a random direction. If you could measure the jittering precisely enough, Einstein said, you could calculate the size of the molecules doing the shoving. The math predicts specific patterns, specific distributions, specific numbers. Perrin measured. The numbers matched. Atoms are real. Molecules are real. Ludwig Boltzmann, dead 2 years by then, buried under 5 symbols in Vienna, was right. The probability framework he built his life defending worked. Statistical mechanics was not metaphysics. It was the architecture of nature itself. This should be the moment of celebration. The music should swell. The hero was right all along, and the proof, while too late to save him, redeemed his legacy forever. Hold that feeling. Hold it for exactly as long as it takes me to say this next sentence. Perrin's proof didn't just vindicate Boltzmann's belief in atoms. It validated the framework beneath that belief. The idea that the universe runs on probability. That the second law of thermodynamics is not an iron commandment, but a statistical tendency. That disorder increases not because it must, but because it is overwhelmingly likely. And that means, on a long enough timeline, the overwhelmingly likely can be interrupted by the astronomically unlikely. That was 1908. Now it is 100 trillion years from now. The last star in the universe has just gone out. Not a dramatic explosion, not a supernova. A red dwarf, small, dim, tenacious, finally exhausting the last of its hydrogen. The nuclear furnace that burned for trillions of years cools, contracts, and fades. What's left is a dense, dark cinder the size of Earth, radiating the last of its heat into a universe that can no longer use it. There are no more clouds of gas to collapse into new stars. No more galaxies colliding to trigger formation. The raw material is spent. Every proton that could fuse has fused or scattered. The age of light is over. What remains? White dwarfs, neutron stars, black holes, stellar corpses, drifting apart in an expanding void that grows colder by the eon. The temperature of space approaches, but never quite reaches, absolute zero. This is the universe's adolescence. Around 10 to the 20 years, 100 quintillion, most remaining matter has been swallowed by the supermassive black holes at the cores of dead galaxies. The universe is now a scattering of black holes in an ocean of near nothing, each one slowly, imperceptibly, evaporating. Stephen Hawking showed that black holes radiate. They lose mass. Particle by particle, photon by photon, over timescales that make the current age of the universe look like the blink of an eye, they dissolve. A black hole with the mass of our sun takes roughly 10 to the power of 67 years to evaporate. A supermassive one, 1 billion solar masses, holds on until about 10 to the power of 100 years. That's a 1 followed by 100 zeros. Then it too is gone. You will not be there to see any of this. No human will. No living thing. These are events that will happen to an audience of nothing. And they are the prologue. Now there is nothing. No stars, no planets, no black holes, no structures of any kind. A dilute sea of electrons, positrons, photons, and neutrinos, each one so far from its nearest neighbor that the distance between them exceeds the diameter of the current observable universe. The temperature is a fraction of a degree above absolute zero and falling. This is heat death, maximum entropy, the state Boltzmann's equation always pointed toward, the overwhelmingly most probable configuration of matter and energy. The universe has finally arrived at the place it was always going, and it will stay here, forever. In about 8 minutes, I'm going to give you a number. It is a number so large that the word large becomes a joke. And that number is how long the universe has to wait before you reappear. Because heat death is not emptiness, it's equilibrium. And Boltzmann, the man on the tombstone, showed that equilibrium is not stillness. It's a constant, invisible vibration. Particles fluctuate. Energy redistributes randomly. Most of the time, these fluctuations are tiny. A photon shifts, an electron drifts, nothing assembles, nothing persists. But probability has no ceiling, and time has no end. In a universe that lasts forever at thermal equilibrium, every possible configuration of matter will eventually occur. Every arrangement of particles, no matter how complex, no matter how improbable, is guaranteed by infinity. A single hydrogen atom assembling from a fluctuation, then two, then a molecule, then, given enough time, a rock, a planet, a galaxy, a brain. How long does the universe have to wait for a brain to fluctuate into existence from pure randomness? 10 to the power of 10 to the power of 50 years. Let me be clear about what that number means, because human language does not have a container large enough to hold it. 10 to the power of 10 to the power of 50 is not 10 to the 50th power. That would be merely incomprehensible. This is 10 raised to the power of 10 to the 50th. The exponent itself is a number with 50 zeros after it. Imagine every atom in the observable universe, roughly 10 to the power of 80 of them, is a clock. Each clock ticks once per billion years. When all of those clocks have ticked more times than there are atoms in the observable universe, you're not even close. You are not a fraction of the way there. You have not begun. The waiting has not started. And at the end of that wait, after a silence so long that every metaphor collapses, particles in the void arrange themselves, by pure statistical chance, into a structure. A structure that can think. A structure that has memories. Memories of a childhood that never happened. Memories of a planet that never existed. Memories of a voice telling it about a man named Boltzmann. In 2004, two physicists at UC Davis, Andreas Albrecht and Lorenzo Sorbo, gave this structure a name. They called it a Boltzmann brain. The name was meant as a warning, a reductio ad absurdum, a way of saying, if your cosmological model predicts this, your model is broken. The problem is that the models aren't broken. The math is clean. The physics is standard. And the conclusion is waiting, patient as a tombstone, for someone to explain why it's wrong. No one has. There is a physicist alive today who read the math we just walked through, sat down, and wrote a paper whose title is 5 words long. Those 5 words are a warning. We'll get to them. A brain, floating in void, with your memories. That's the prediction. But we haven't asked the question that actually matters, the one that makes physicists sit very still for a very long time. Not could it exist, not when would it form. The question is closer than that. The question is inside you right now, in the space between this word and the next. How would you know if you were one? Here is a thought experiment. Once you've heard it, it will follow you into every room you enter for the rest of the day. Possibly longer. Close your eyes. Not literally, keep listening, but imagine that you have closed them. Imagine darkness. Now imagine that in that darkness, right now, a brain materializes. Not grows, not evolves, not develops over billions of years through the slow machinery of natural selection. It simply appears. A spontaneous arrangement of particles, assembled by pure statistical chance from the quantum vacuum of a dead universe. This brain is not empty. It is not a blank organ waiting for input. It arrives loaded. It has memories, specific ones. It remembers a childhood, a specific house, a specific street, the smell of a specific kitchen. It remembers learning to read. It remembers its first heartbreak. It remembers sitting down to watch a video about physics, about a man named Boltzmann, about a tombstone in Vienna. It remembers the last 30 seconds of this sentence. This thought you're having right now, that this is absurd, that obviously you're real, that you have a body and a history and a continuity of experience that can't be faked, A Boltzmann brain would have that exact thought, that exact confidence, that exact dismissal. It would feel the weight of its own hands. It would feel the breath in its lungs. It would have no reason to doubt anything, because every piece of evidence it could consult, every memory, every sensation, every chain of reasoning, arrived pre-installed. This is not philosophy. This is what the equations say. The 5 words I promised you. They belong to Sean Carroll, a theoretical physicist at Caltech who has written about the Boltzmann brain problem more clearly than almost anyone alive. Carroll once described this paradox as the thought that makes cosmologists stare at the ceiling. The thought where the math is easy. Too easy. The answer keeps coming out wrong, and wrong in a direction that points back at the person doing the math. In 2017, Carroll published a paper. Its title, Why Boltzmann Brains Are Bad. The title sounds almost casual. The paper is anything but. What Carroll published was not a dismissal. It was a diagnosis. He examined the logical structure of any cosmological model that predicts Boltzmann brains and found something specific. Not that the models are wrong, something worse. He called it cognitive instability. Here's what that means. Suppose you accept a cosmological theory that predicts most observers in the universe are Boltzmann brains, random fluctuations with fabricated memories. If most observers are Boltzmann brains, then you are probably a Boltzmann brain. If you are a Boltzmann brain, then all of your memories are false. If all of your memories are false, then the scientific evidence you use to build the cosmological theory is also false. Which means the theory that told you you're a Boltzmann brain cannot be trusted, which means you have no reason to believe you're a Boltzmann brain, which means the theory might be correct, which means you probably are one. The loop doesn't resolve, it tightens. Carroll called theories like this cognitively unstable. They cannot simultaneously be true and justifiably believed. You can't stand on the floor and prove the floor exists if the floor might be a hallucination. You can't use your eyes to verify that your eyes work. You can't think your way out of a trap that's made of thought. For a moment, this seemed like enough. The paradox had a name. The name sounded like a solution. If Boltzmann brain theories are cognitively unstable, we should simply reject them. Pick cosmological models that don't produce this problem. Move on. That was the resolution. Clean. Elegant. Done. Then in December 2025, 3 physicists, David Wolpert at the Santa Fe Institute, Carlo Rovelli, and Jordan Scharnhorst, published a paper that took the floor out from under Carroll's floor. They didn't disagree with Carroll exactly. What they did was more precise and more devastating. They showed that the standard arguments against Boltzmann brains, including cognitive instability, rely on assumptions about time, memory, and entropy that are not given to us by physics. They're choices we make. Specifically, when we say, "My memories are reliable records of the past," we are not stating a physical law. We are making an inferential decision, choosing to treat the present moment as the result of a real history rather than as a random fluctuation. Physics permits both interpretations. The equations don't tell you whether your memories are recordings or fabrications. They are equally consistent with both. The arrow of time, the feeling that the past is fixed and the future is open, is not carved into the laws of nature. It's something we impose on the math because it matches our experience. But if our experience might be a fluctuation, then using our experience to validate our experience is the definition of circular reasoning. This is the part of the research where the page went blurry and I had to read it 3 times to make sure I wasn't misunderstanding something. I wasn't. Let me state the math plainly. In any cosmological model where the universe persists beyond approximately 10 to the power of 166 years, and our current best fit model, the one that accurately predicts cosmic expansion, background radiation, the distribution of galaxies, allows exactly this, the number of Boltzmann brains that will fluctuate into existence exceeds the number of ordinary observers by a factor that approaches infinity. Not a large number, not a number with many zeros, a ratio without boundary. This is what the math says, not might say, not could imply. says. In every cosmological model where the universe lasts long enough, hallucinated observers outnumber real ones by a margin so large that the number has no name. You are, by the most conservative estimate physics can offer, almost certainly a momentary fluctuation that believes it is a person. Actually, that's not the right word. There is nothing conservative about this. This is the math at its most restrained, and it's still screaming. The thing that separates this from a late-night dorm room argument is that this conclusion is reached using the exact same physics that told you atoms are real. The same framework, the same equations, the same S equals K log W that a grieving family carved into a tombstone in Vienna. You cannot accept the physics that builds your phone and lights your cities, and then reject it when it points its finger at you. It's one system, one math, one set of rules that works everywhere, at every scale, without exception. Unless it's wrong. And it's not wrong. Not about atoms, not about entropy, not about the second law, not about anything we've ever tested. It's just that we've never tested it on you. There is a gap between what physics can calculate and what physics can confirm. Inside that gap, something floats. Not yet real, not yet disproven, not yet understood. A brain. Your brain. Or something wearing your brain like a mask. So, the math says you're probably not real. The attempt to disprove it collapses into itself. Is there a way out? There is. But you're not going to like what it costs. There are exactly 3 proposed solutions to the Boltzmann brain problem. I need you to understand something before I list them. These are not 3 options on a menu. They are 3 locked doors, and behind every one of them is the same room. Solution 1. The universe dies. In 2013, Sean Carroll and a physicist named Kimberly Boddy published a paper with a title that sounds like it belongs on a comic book. Can the Higgs boson save us from the menace of the Boltzmann brains? It is not a comic book. It is a paper about whether the fabric of reality is scheduled to tear itself apart, and whether that destruction is the only thing keeping you real. Carroll later said the Boltzmann brain problem was the one that followed him home from the office. Not because the math was hard, but because the math was easy, and the answer kept arriving at the same terrifying place. Here's what they proposed. The Higgs field, the quantum field that gives particles their mass, the field whose existence was confirmed at the Large Hadron Collider in 2012, might be unstable. Not obviously unstable, metastable, meaning the vacuum of space, the emptiness between atoms, the nothing that everything floats in, might not be the lowest energy state available. There might be a lower one. And if the Higgs field ever tunnels down to that lower state, through a process called vacuum decay, the transition would propagate outward at the speed of light. A bubble of new physics expanding from a single point, rewriting the laws of nature as it goes. Every atom it touches would be reconfigured into something that can no longer hold the shape of a star, a planet, a thought. The bubble would be undetectable until it arrived. You would not see it coming. You would simply stop. Carroll and Boddy's argument was this. If vacuum decay happens fast enough, if the universe collapses into a lower energy state before 10 to the power of 10 to the power of 50 years have passed, then Boltzmann brains never have time to dominate. The void never lasts long enough for random fluctuations to assemble observers. The paradox is killed, not by logic, by annihilation. The price of your reality is the death of the universe, and not in some distant, abstract, poetic sense. In the specific sense that the laws of physics must contain a self-destruct timer. The cosmos has to end, violently, completely, and on schedule, or the math says you're a hallucination. Would you trade the existence of the universe for the certainty that you're real? Don't answer yet. Solution 2. Dark energy fades. The reason Boltzmann brains require an infinite future is the cosmological constant, the tiny but non-zero energy woven into empty space that drives the universe's accelerating expansion. If this energy is truly constant, the universe expands forever. Forever means infinite time. Infinite time means infinite fluctuations. Infinite fluctuations means Boltzmann brains win. But what if dark energy isn't constant? What if it's a field, something called quintessence, that slowly weakens over cosmic time? If dark energy eventually drops to zero or turns negative, the universe doesn't last forever. It either coasts to a halt or collapses back on itself. Either way, the infinite future disappears, and so do the Boltzmann brains. The problem: every measurement we've made of dark energy is consistent with it being exactly constant. We have no evidence it's fading. We have no mechanism that predicts it should. This solution asks us to hope that the universe is built differently than it appears to be, because the alternative is unbearable. That's not physics. That's prayer. One door left. Solution 3. Redefine what it means to be conscious. A Boltzmann brain exists for a nanosecond, maybe less. It flickers into configuration, holds a single momentary state, and dissolves back into thermal noise. Does that count? Does a nanosecond of the right particle arrangement constitute experience? Does a brain need history to be conscious, a causal chain stretching back through time? Or is the instantaneous pattern enough? If consciousness requires causal history, if you need to have actually lived the life you remember in order to be aware, then Boltzmann brains don't think. They're not observers. They're just brief, meaningless arrangements of matter that happen to look like observers from the outside. The paradox evaporates because the brains don't count. But this is philosophy, not physics. And the paradox was born in physics. You can't escape a mathematical trap by changing the definitions of words. The equations don't know what consciousness is. They don't care. They count configurations. And by configuration count, you lose. 3 solutions, and each one promises escape. But each one requires either the destruction of the universe, the revision of fundamental physics, or the solution to a problem no human has ever solved. The exit doesn't exist. Every door opens back into the room you're already standing in. There's a philosopher named John Norton at the University of Pittsburgh who framed the trap more precisely than anyone. He pointed out that the Boltzmann brain scenario is structurally identical to Descartes' evil demon, the all-powerful deceiver who fabricates every experience you've ever had. In 1641, Descartes imagined this demon as a thought experiment. He had no mechanism, no physics, no equation, just the unsettling idea that all of experience could be fiction. Boltzmann's equation provided the mechanism. S equals K log W. Entropy equals probability. And given enough time, probability will build anything, including a perfect counterfeit of you. Descartes imagined a demon because he was afraid. Boltzmann calculated one because he was right. The demon is not supernatural. It's not a simulation. It's thermodynamics. It's the same physics that tells you water boils at 100 degrees and iron rusts in rain. Applied across an infinite timeline, it manufactures liars. Liars made of atoms. Liars who don't know they're lying. And Norton pressed further. If all your evidence is potentially fabricated, if every memory, every experiment, every measurement might be the content of a fluctuated brain rather than a real history, then science itself dissolves. Not metaphorically. If you're a Boltzmann brain, then the experiments that confirmed general relativity never happened. The data behind the Standard Model is fiction. Perrin never proved atoms exist. Boltzmann never lived. The equation on the tombstone was never carved, because the tombstone was never real, because Vienna was never real, because nothing was ever real except a momentary shudder of particles in a void that doesn't remember you. This is the thing I've been building towards since the first sentence of this video. Not the paradox itself. The paradox is just math. What's devastating is the completeness of the trap. Every tool you could use to escape was built inside the trap. Your logic, your evidence, your memory of hearing me say this. The trap is made of you. 3 doors, same room. And the room is the one we started in. Remember the man at you.No. Remember why I started there. We're going back to that bay. But first, I need to tell you the most disturbing thing about Ludwig Boltzmann's death. Not how he died, you know that. Not why, no one knows that. The most disturbing thing is this. If you are a Boltzmann brain, then Ludwig Boltzmann never existed. His suffering was never real. The tragedy you felt in the first minutes of this video, the grief for a man destroyed by his own colleagues, was manufactured from nothing. You mourned a fiction. And the mourning felt real because the thing doing the mourning isn't. There is a tombstone in Vienna, 5 symbols. Let me tell you what they actually mean. September 5th, 1906, afternoon. The Bay of you.No. I want you to see it. Not as history, not as biography. As the last frame of a film that started 13.8 billion years ago with a universe-sized explosion and ended in a hotel room with a piece of rope. The water is calm. The Adriatic in September is still warm enough to swim without bracing yourself. Henriette and Elsa are in the bay. Maybe they're talking to each other. Maybe they're floating in silence, the way people do when the summer is ending and they know it. The light is the kind you get on the Italian coast in late afternoon. Amber, heavy, almost liquid. It makes everything look like a painting of itself. Inside the hotel, Ludwig Boltzmann is alone. I don't know what he was thinking. No one does. There was no note, no final letter, no last equation scrawled on a napkin. Just a man in a room with a decision already made. And outside, the sound of water and the ordinary continuation of a world that hadn't yet noticed what it was about to lose. He was 62. His eyes were too weak to read. His mind, by his own terrified admission, was beginning to fail. He lived in constant fear that one day, mid-lecture, mid-sentence, mid-thought, the machinery would simply stop, and he would stand there in front of a room full of students with nothing behind his eyes. He'd spent 30 years defending an idea that the most powerful voices in physics called a delusion. And the cruelest part, the part that I keep returning to, is that he was right. He was right about all of it, and he died without knowing. 2 years later, Perrin proved atoms exist. 5 years later, Einstein's framework was standard physics. 20 years later, quantum mechanics, built on the statistical foundation Boltzmann laid, was the most successful theory in the history of science. S equals K log W, the equation on his tombstone. Let me tell you what it actually says. S is entropy, the measure of disorder, the thing that always increases, the reason glasses shatter and never reassemble, the arrow that points every process in the universe toward its most probable state. K is Boltzmann's constant, a number. 1.380649 times 10 to the negative 23 joules per Kelvin. His name, permanently embedded in the conversion rate between energy and temperature. A dead man's initial, lodged in the machinery of nature forever. W is the number of microstates, the number of ways the atoms in a system can be arranged while still looking the same from the outside. The bridge between the invisible and the visible. The thing that turns atomic chaos into thermodynamic law. And log is the link. The mathematical function that connects probability to physics, that turns counting into meaning. S equals K log W. Entropy equals probability. This is the equation that proved Boltzmann's critics wrong. It showed that the second law of thermodynamics is not magic, it's math. It's the reason heat flows from hot to cold, the reason time moves forward, the reason the universe ages. It is, by any honest accounting, one of the most important equations ever written by a human being. It is also the equation that makes you less likely than a hallucination. Because if entropy equals probability, and if probability governs everything, and if the universe lasts long enough for every probability to be realized, then the equation on that tombstone doesn't just describe the universe, it generates observers, random ones with memories of lives they never lived, ones who believe they are standing in a cemetery in Vienna, reading an equation, feeling the weight of a dead man's legacy, when in fact, they are a flicker of organized matter in an infinite void, and the cemetery and the equation and the legacy are all part of the flicker. The memorial is the threat, the tribute is the weapon. The 5 symbols that honored a man's life's work are the same 5 symbols that dissolve the concept of a life. I want to go back to the bay one more time. Henriette and Elsa are swimming. The water breaks against skin. The light is amber. And somewhere in the future, in a future so distant, particles in an empty universe will fluctuate into a configuration that contains this exact scene: the bay, the light, the sound of water, the grief. A brain that carries this memory will exist for a nanosecond in a void where no bay, no light, no water, and no Boltzmann have ever been real. And that brain will feel this. It will feel the weight of this story. It will believe it has been listening for 33 minutes. It will mourn a man it never knew, in a universe that never existed, with a sadness that is, in every measurable, testable, physical sense, indistinguishable from yours. Do you know which one you are? I don't. The equations don't tell me. They are silent on this particular question, in the same way that gravity is silent on the meaning of falling. The math gives you probability, not identity. It counts configurations, not souls. Ernst Mach stood up in a room full of physicists in 1897 and he was wrong. Atoms exist. Perrin proved it. The Nobel Committee confirmed it. The phone in your pocket runs on it. Mach was wrong about atoms. But strip away the specifics. Forget the atoms. Forget the microscopes and the Gamboge and the Nobel Prize. Listen to the shape of what Mach was saying. He was saying, you cannot point at something invisible, something you've never directly observed, something that exists only as an inference from indirect evidence, and call it real. He was pointing at atoms. The Boltzmann brain paradox is pointing at you. And the question it asks is Mach's question, wearing different clothes. Can you believe in something you cannot see, cannot test, cannot prove from the inside? Mach asked this about atoms and was wrong. But when the same question is aimed at your own existence, when the thing you cannot prove is not a particle but a person, the answer doesn't come as easily. S equals K log W. The equation doesn't care who reads it. Carved in stone in a Viennese cemetery, it receives tourists and rain with equal indifference. It does not know that the man beneath it suffered. It does not know that his work was vindicated. It does not know that 120 years later, the deepest consequence of its 5 symbols is a question that no physicist, no philosopher, no fluctuation in the vacuum of a dying universe has ever answered. The question is not, what is entropy? The question is not, what is probability? The question is not even whether Boltzmann brains exist. The question is the one you're asking right now, silently, in the space behind your eyes, in a voice that might be yours or might be noise. And the equation doesn't answer. It never has. It sits in the stone, 5 symbols, carved once, meaning everything, patient and certain